So far, we have seen void pointers and other concrete data type pointers as well. It was mentioned that void pointers can hold function pointers too. Let us see what are function pointers in this section. As we have discussed earlier in this lesson, the compilation process converts your program into a sequence of executable instructions. At runtime, these instructions are executed in the primary memory of your system. For the sake of simplicity, let us assume that all the instructions of a function have been loaded in a contiguous stretch of the primary memory. The base address of this contiguous stretch of memory can be accessed with the function name. Let us take an example to understand this better. This is our sample program which consists of only one statement. At the time of its execution, the compiler binary bytes of the program will be loaded into the primary memory, occupying a continuous stretch of memory. Please note that the textual form of the program shown in the primary memory is just for representation. In reality, the executable bytes are loaded into the primary memory. The base address of the continuous stretch of memory where the compiled instructions of a function are loaded will be available in a variable named myFunction. You do not need to create or initialize this variable. The compiler and the C runtime do it for you. For example, this statement will not throw an error. Instead, it will print a legitimate address. The value being shown on your screen is a hexadecimal representation of 112, which is the base address of the memory chunk occupied by the function. Since the base address of a function is just an address, it can be stored in a pointer type variable. For example, in this statement, we have assigned the base address of my function to a void pointer. This is a perfectly legal statement but of no use because the void pointers cannot undergo any built-in pointer specific operation. Their only purpose is to store memory addresses. We have seen in the previous section that in order to apply pointer specific operation like dereferencing, the compiler needs to know the data type or the nature of the pointer. For example, if the address held by the void pointer is the base address of an integer variable, the void pointer needs to be casted into an integer type pointer before it can be meaningfully dereferenced, or it should have been declared as integer type pointer instead of being declared as void type pointer. In a similar tone, what if we need to perform a pointer specific operation over a pointer which is holding the base address of a function? Indeed, in this case too, the pointer either need to be cast into a function pointer or should have been declared as a function pointer to begin with. This brings us to the stage where we need to understand how to declare and define function pointer, which is our next topic of discussion. This is the general syntax of declaring a function pointer. The function pointer declaration starts with the return type of the function, followed by a pair of common brackets which contain an asterisk, followed by the name of the function pointer, which is again followed by a pair of common brackets containing the data type of the function argument in the same order as contained in function definition. Let us understand this through an example. Consider the example of a function which returns an integer and accepts two arguments. The data type of the first argument is int and of the second argument is float. The function prototype of such a function will look like this. The declaration of a function pointer to hold the base address of such function should be like this, where funPTR is the name of the function pointer. We already know that the name of the function is synonymous with the base address of the function. Therefore, the above statement can be rewritten as this, where my function is the name of the function. Let us know how to call a function by making use of a function pointer. If this is the function prototype, then this is how we call the function funName by making use of its pointer. When the C runtime encounters this statement, since funPTR has been declared as a function pointer holding the base address of function named myFunction, the runtime knows exactly what to do, which is interpreting the pointer as a function pointer and calling the function whose base address is held by funPTR. You should have noticed that calling a function through its pointer is very similar to calling the function through its name. The utility of calling a function through its pointer will become more clear in the next video, which will cover problems on pointers. For a better understanding, let us see a complete working example. In this example, the first few lines declare and define a function fun which accepts an integer as its single argument and return nothing. The first line in the main function declares a function pointer funPTR and initializes it with the pointer of fun function using the name of the function. Finally, the second line makes a call to the function fun using the function pointer. You should carefully note that the style of declaration of the function pointer and also the style of calling the function by making use of function pointer. This example brings us to the conclusion of this lesson. In this lesson, we talked about pointers and some of the related concepts like obtaining the base address of variable and dereferencing memory addresses and their applications. Do not forget to watch the next video, which will discuss some interesting problems on pointers, including problems on function pointers. Thanks for watching.